Prabha. Digital India. Educated India.
And that's exactly what is being shown here. This is one of the slabs, and at the joint you have provided these dowels, and you will be casting the next concrete in this location so that it simply connects to the adjacent slab. Okay, this is an example of a roadway pavement which is being just made. Okay, you see the granular material at the base, granular base is seen, and the concrete is going to be poured on top of this. Okay, and they have already defined the location of the dowels in the direction of traffic. So this is the traffic direction, that's the traffic direction, and they've defined the dowels, they've placed the dowels already before putting the concrete, right, and then they'll be putting the concrete on top here, filling up the concrete on the top. Now dowels are provided to connect the slabs in the longitudinal direction, so this is the longitudinal direction. You can also have dowels provided in the transverse direction. Okay, so dowels are also provided to connect the slabs in the transverse direction. So both ways there is good load transfer between one slab to the next. So that's the use of a dowelled pavement. Again, a close-up view is shown here. These dowels are placed exactly where the joint is supposed to come between adjacent slabs. So then you will be pouring the concrete on one side and then pouring the concrete on the other side, just like what is shown in this case. Okay. Of course, a continuously reinforced concrete pavement is nothing but a regular reinforced concrete slab which has reinforcement in both directions. It's got reinforcement in both directions. So that's what you see here in a close-up. The reinforcement is actually extending in both directions. So here there are no joints. See the roadway surface, there are no joints in the concrete. That's because the shrinkage and thermal effects are taken care of by the reinforcement directly. You don't need to provide joints and provide dowels across the joints. Okay. So here the bottom picture you see, before the construction process you have the reinforcement mat which has been laid out, and then these are small, not really cover blocks, they are called chairs, to ensure that you can increase the height at which the reinforcement is placed. You don't want to place it directly on the ground because it should not be in the surface contact with the ground, otherwise it will get corroded. It is usually placed directly in the center of the rigid concrete slab. Okay. So to place it in the center you need to raise it above the ground, and to raise that you need to provide these arrangements which are called chairs. Okay. They are called chairs, again made with steel, essentially to make the steel mat sit a few centimeters above the ground level. See, most pavements are pavement thickness is typically about 150 to 200 millimeters, or sometimes it could be 300 also. Yeah, so 150 to 300 mm. In most cases, when you are talking about highway pavements, you are closer to 300 mm. Okay, when you are talking about driveways outside the building, right, which are only going to be taking the load of one or two vehicles, in those cases obviously you can reduce the thickness. So you need to design the pavement so that the thickness is controlling the extent of stress that can be felt by the concrete. So remember, I told you that the concrete has to behave like a slab to resist the loading of the vehicles. So the thicker the slab, the greater will be its moment of inertia in the direction of bending. Okay, the greater the moment of inertia, the lower will be the stress that will be felt by the concrete. So you need to design it appropriately so that the concrete does not crack in tension. Now, in some cases, the concrete pavements, after completion of the slab placement, after completion of the concrete placement and finishing, you have to provide texturing of the pavement surface. Remember, we talked about this briefly in the concrete chapter also. After finishing, right, there is some texturing that is done. This is one example of the texturing called brooming. So this broom, which has very rough bristles, is rubbed on the top surface of the concrete. So concrete is not completely hard at that point of time, it still has some it has not achieved its final set, okay. So it can be altered, the surface can be altered by brooming, and this brooming ensures that you get a good grip on the road surface when the pavement moves on it, okay. You then have another aspect called tining. Tining is after the concrete surface has become hard, we take this sort of a grooving, not very hard but somewhat hard, we take this grooving tool and cut a groove on top. This is not a cut rather, but it's just a small groove that is provided on top. So if this is your pavement, I am just providing a very small groove at small distances. This is not a crack, this is not a joint, but this is just a grooving done on the pavement surface. So we are talking about a few millimeters, right? Maybe about less than 5 millimeters of the groove is actually created on the concrete surface. And you see that this is the direction of traffic, and the tining is done along the direction of traffic. What does this tining do? It helps in providing, first of all, good grip, especially in the case of wet conditions. When the conditions are wet, the tining helps to increase the grip of the tire on the surface. So it's a very good thing to do for concrete pavements, okay. So depending upon what you need in terms of the performance, you can have different types of pavement textures, and that's what is shown here on the top here. Different pavement textures, for example, roughness is of the order of a few millimeters, 1 to 10 millimeters. Okay, this is called roughness basically, which is of the order of 1 to 10 millimeters. Then you have what is called mega texture, which is about 0.1. Okay, and as you go smaller and smaller, you go to macro texture and micro texture. Okay, so what are these textures? What kind of performance are these textures affecting? The roughness obviously affects the rolling resistance. The micro texture is what is responsible for the wearing off of the tire slowly. Okay, wet pavement friction is taken care of by micro and macro texture. So you need to ensure that the size of the tining grooves that you give are of this order, right, to provide the right level of holding on the pavement surface. Exterior noise, interior noise, which is caused because of the interaction of tire with the pavement, can also be related to the texture of the pavement. So sometimes this tining also helps to reduce noise. Okay, oftentimes tining will also help to reduce noise. So again, all these aspects, the textures, can be taken care of on the surface, okay, by providing all these inputs. Now what do we, just like asphalt pavements, we had some specific properties that we desired from asphalt pavements. In concrete pavements, what do we need? Obviously we need strength, mostly we need tensile strength. We also need abrasion resistance, because as the vehicles are moving continuously on the surface, concrete will continuously get abraded, right? So abrasion resistance and fatigue resistance is also needed, because in buildings we don't really take fatigue, but here we have to also take up fatigue resistance. Cracking resistance is very important. Cracks, as I said, may happen because of shrinkage of concrete, curling or warping, both of which are related to heat and moisture. Okay, skid resistance is important on a concrete surface, right? And of course the riding comfort. Now, because these joints are present, the riding comfort on a concrete pavement is sometimes not as good as that you find on a flexible asphalt pavement. So very often what is done in countries abroad is that even though your main structural pavement is actually a concrete rigid pavement, they sometimes use a surfacing of asphalt concrete on top of the concrete pavement. They put a surface layer of asphalt concrete on top of the concrete pavement. That's an interesting example of a composite sort of a pavement deck. Okay, so these are the properties that you want from typical concrete pavements. Now just to give you a bird's eye view of why one should consider one pavement on top of the other, the main considerations with respect to choice of one or the other is the initial cost and the ease of construction. I already talked about this briefly earlier. The initial cost and the ease of construction both point towards a benefit for flexible pavement made with asphalt concrete. Okay, cost is low, it's very easy to construct as opposed to cement concrete pavement. Now the maintenance cost and service life how long is the payment going to serve satisfactorily? And in that case, the concrete pavement is the winner. Okay, so here you have asphalt concrete, here you have cement concrete. So because it's easy to maintain over a long period of time, if you've done a good job of the construction, the maintenance cost of a cement concrete pavement is not much at all. On the other hand, asphalt concrete, because of the polymeric nature of the asphalt and its capability for getting degraded because of multiple effects, you can have a lot of issues with maintenance. Okay, ease of repair. Now in ease of repair, again your asphalt concrete scores. We talked about surface recycling, we talked about surfacing itself. In some cases you may have seen that in your neighborhoods, whenever a road pavement gets damaged and a VIP is visiting, you immediately have in the night some sort of a contractor who comes there and just puts a new surface of asphalt pavement on top. Just a thin asphalt pavement layer is put on the surface of the road. They have not repaired any damage, all they have done is resurface the road. Okay, so ease of repair and refurbishment of a damaged pavement is much better in the case of asphalt concrete. In cement concrete, if the pavement slab breaks or starts cracking, you have to remove the entire thing and put a new thing back. It's not easy to repair it in that case. Rider comfort. How comfortable are the riders inside? We talked about this earlier, that in concrete pavement, when you have joints, it affects the comfort of the rider. So it's not good from that perspective. Again, here the asphalt concrete pavement basically scores. There may be other riding issues like skid resistance, right? In some cases, reflectivity also may be an issue. When you're driving in the night, the asphalt concrete pavement, which is black, may not really have the reflectivity unless, of course, the polish on the surface is good and the aggregates are able to reflect some light. That's why you need to provide all those markers or indicators to ensure that people are moving in the right lane. Concrete pavement, on the other hand, reflectivity is better. So you need to consider issues like skid resistance, reflectivity and so on. Right, all these aspects. So here skid resistance probably more or less equal. Reflectivity, it's better with cement concrete pavement. Okay. Tire pavement interaction noise, the noise generated when the tires interact with the pavement, right? That noise is generally much lower for asphalt concrete. So asphalt concrete pavements are more silent as opposed to cement concrete pavements where a lot of noise is generated. That's why we have to do the texturing on the cement concrete pavement. So the question now is, can a winner be picked between asphalt and cement concrete? The choice is obviously dependent on the person who's using the pavement. Now if I am an agency or if I am the client like the municipal development corporation in a city, I need to make a choice. What is more important for me? Is the ease of application or ease of repair, initial cost, all those are important, or is it the maintenance cost and the long-term performance of this pavement that is important? The other aspect when you're talking about pavements in a city is that oftentimes we have our water lines and electricity lines under the pavement. When you have an asphalt concrete pavement, it makes it all that much more easier to do this, to access the pipes underneath and then resurface the road. Cement concrete, again, a lot of effort is involved in actually breaking open the concrete. So there are a lot of things that you need to consider in order to be able to properly choose between cement concrete and asphalt concrete pavement. Okay, so I'll not give my own opinion here, but I'll leave the choice to all of you to really think about it from different perspectives, from a user's perspective, from the operation perspective, operation and maintenance perspective, from the owner's perspective, like the National Highway Authority of India, NHAI, from their perspective, what do you think should be the ideal way to construct a pavement? Is it asphalt concrete or is it cement concrete? Okay, so with that, we'll complete this chapter, and also this is the last chapter in this course. I hope this course has been very useful for you and it will build up your foundation for higher level courses in civil engineering. I'm also providing some references here. There are a lot of references on asphalt concrete that you find in conventional construction materials books also. But of course, understanding asphalt is critical from the point of view of appreciating the way that asphalt concrete pavements behave. So I would really urge you, in case you are interested in asphalt, to take up higher level courses in transportation materials to really satisfy that desire to learn about asphalt. Okay, so thank you all very much, and it's really been wonderful for us to bring up this course for all of you, and I hope that it's useful for all of you. Thank you.